Welcome to this comprehensive lecture on how artificial intelligence tools can systematically help you conduct research and publish high-impact scientific papers. Over the next 16 minutes, we'll explore the full research pipeline, from literature review to publication, and how to use AI ethically throughout this journey. Here's the complete research pipeline. We start with literature review, move to experimental design, then data analysis, and finally writing and publishing. AI can assist at every single stage of this process. Let's start with the literature review phase. This is where most researchers spend countless hours. Let me ask you a question. How many papers do you think are published every year in biomedical research alone? The answer is staggering. Over 1 million papers are published every year just in biomedical research. That's about 2 papers every minute. Imagine trying to keep up with that using traditional methods. Let's do a quick back-of-the-envelope calculation. If each paper takes you 30 minutes to read thoroughly and you want to review just 100 papers for your literature review, how long would that take? 100 papers times 30 minutes equals 3,000 minutes. That's 50 hours of continuous reading. If you read 8 hours a day, that's over 6 full working days just to get through 100 papers. This is where AI tools, like Semantic Scholar and Connected Papers, come in. These aren't just search engines. They're intelligent systems that understand the semantic relationships between papers. Here's how it works. You start with one seed paper that you know is relevant. The AI analyzes citation networks, semantic similarity, and co-citation patterns to build a graph of related papers. It's like having a research assistant who has read millions of papers and can instantly tell you which ones are most relevant. Let me give you a humorous but real example. Imagine you're studying the effect of coffee on cognitive performance. There are probably 10,000 papers on coffee and another 10,000 on cognitive performance. But you specifically need papers on coffee's effect on mathematical problem-solving in sleep-deprived graduate students. Traditional search would give you 20,000 irrelevant papers, but AI-powered semantic search can find that one perfect paper that studies exactly what you need. It's like having a metal detector in a haystack instead of using your hands. Once you've found your papers, the next challenge is synthesis. This is where large language models like ChatGPT and Claude become incredibly powerful. But here's a critical question. Can we trust AI to summarize scientific papers accurately? The answer is yes, but with verification. Think of AI as a very smart graduate student who sometimes makes mistakes. You wouldn't publish your grad student's summary without checking it, would you? Here's what AI can do. Take a 20-page paper and distill it into 2 clear paragraphs highlighting the key methods, results, and conclusions. This reduces your reading time from 30 minutes to maybe 5 minutes per paper. Let's calculate the time savings. Instead of 50 hours for 100 papers, you now spend maybe 10 hours using AI-assisted summaries, plus another 5 hours spot-checking the original papers for critical details. Traditional method, 50 hours. AI-assisted method, 15 hours. That's a 70% reduction in time. You just saved 35 hours, which is over 4 full workdays that you can now spend on actual research instead of reading. Now let's move to the experimental design phase. This is where AI becomes really interesting, because it can help you avoid common pitfalls and optimize your experimental parameters. Here's a question for you. What do you think is the most common reason experiments fail in the lab? The answer is poor statistical power and inadequate sample sizes. Researchers often don't calculate the minimum sample size needed to detect an effect, leading to underpowered studies that waste time and resources. On the left, we have an underpowered study with only 10 samples. It can't detect real effects, even if they exist. On the right, a well-powered study with 50 samples gives you reliable results. AI tools can calculate the exact sample size you need based on your expected effect size and desired statistical power. AI-powered statistical tools can help you design better experiments. They can run thousands of simulations in seconds to determine optimal sample sizes, randomization schemes, and experimental conditions. Here's a funny analogy. Imagine you're testing whether chocolate chips make cookies tastier. You bake 1 chocolate chip cookie and 1 plain cookie, and you conclude, chocolate chips make no difference because your roommate liked both equally. That's clearly ridiculous, right? But this is essentially what underpowered studies do. AI tools would tell you that you need to test at least 30 people with multiple cookies each to draw a valid conclusion. Now we arrive at the data analysis phase, and this is where AI tools really shine. Modern AI can help with everything from data cleaning to advanced statistical analysis to machine learning model development. Here's the flow. You have raw, messy data with missing values, outliers, and inconsistencies. AI tools can automatically detect and handle these issues, transforming your messy data into clean, analysis-ready datasets. This process that used to take days now takes minutes. Let's calculate the time savings for data cleaning. A typical dataset might have 10,000 rows and 50 columns. Traditional manual cleaning could take 20 hours. Manual cleaning, 20 hours of tedious work. With AI tools like Pandas profiling and automated outlier detection, this drops to 2 hours, including validation. That's a 10-fold increase in efficiency, and you're less likely to make mistakes because you're not manually checking thousands of cells. For the actual analysis, AI code assistants like GitHub Copilot are game changers. They can write statistical analysis code, create visualizations, and even debug your scripts. You type a comment describing what you want to do, and Copilot suggests entire functions. It's like having a senior data scientist looking over your shoulder, suggesting best practices and catching errors before they happen. Now let's talk about ethics, because this is crucial. The first ethical consideration is that you must understand what the AI is doing. You cannot blindly accept AI-generated code or analysis without understanding it. On the left is the wrong approach, copying AI-generated code without understanding what it does. This is like copying homework without learning. On the right is the correct approach, using AI as an assistant, but verifying the logic and understanding every step. Let me tell you a humorous but cautionary tale. A researcher once asked AI to find correlations in their dataset. The AI found that ice cream sales were strongly correlated with drowning deaths. The correlation was 0.95, very strong. So does ice cream cause drowning? Of course not. Both increase in summer. This is the confounding variable problem. I found the correlation, but it took human insight to realize it was spurious. Now we reach the writing phase. This is where tools like ChatGPT, Claude, and specialized academic writing assistants can dramatically speed up the process. But again, ethics are paramount. The workflow is simple. You write a rough draft with your ideas and results. Then AI helps polish the language, improve clarity, and ensure proper academic tone. The key is that the ideas and scientific content must come from you. Here's ethical consideration number 2, proper attribution. You must be transparent about how you used AI in your research. Many journals now require this disclosure. You must disclose if AI helped with literature review, if AI assisted in data analysis code, if AI helped with language editing, or if AI contributed to figure generation. What's generally acceptable? Using AI for grammar checking. Using AI to improve clarity of already written text. Using AI tools for routine data processing, and using AI to generate visualization code. What's not acceptable? Having AI write entire sections without your input. Using AI to fabricate data or results, having AI make scientific conclusions without human verification, or failing to disclose AI usage when required. The line is clear. Unethical. AI writes the paper, and you just submit it. Ethical. You write the paper with your ideas and research, and AI helps polish and improve the presentation. Let's talk about using AI for figures and visualizations. Modern AI tools can create publication-quality figures, but you need to ensure they accurately represent your data. AI can take your basic scatter plot and transform it into a publication-ready figure with proper formatting, error bars, statistical annotations, and professional styling. But remember, the underlying data must be yours and accurate. Let's calculate the time savings for manuscript preparation. Writing a typical research paper might take 40 hours without AI assistance. Traditional writing. 40 hours from first draft to submission-ready manuscript. With AI assistance for language polishing, reference formatting, and figure generation, this drops to 25 hours. That's another 15 hours saved, which is almost 2 full workdays that you can spend on research instead of formatting. Now let's add up all the time savings across the entire research pipeline to see the cumulative effect of using AI tools ethically and effectively. Literature review saves 35 hours, experimental design saves 10 hours, data analysis saves 18 hours, and manuscript writing saves 15 hours. That's a total of 78 hours saved. 78 hours divided by 8 hours per workday equals almost 10 full working days saved on a single research project. That's nearly 2 weeks of your life back to spend on more research, more experiments, or finally taking that vacation you've been postponing. But here's an important question. Should we use this saved time to publish more papers or to publish better papers? This is a fundamental question about how AI changes scientific research. On the left is the quantity approach, using AI to publish more papers, even if each is less impactful. On the right is the quality approach, using AI to free up time for deeper thinking and breakthrough research. The scientific community generally values quality over quantity. This brings us to ethical consideration number 3, the reproducibility crisis. AI can help solve this problem if used correctly, or make it worse if used carelessly. I can help reproducibility by automatically documenting every step of your analysis, generating version-controlled code that others can run, creating detailed method sections, and standardizing statistical approaches. But AI can hurt reproducibility if you don't save the AI-generated code, if you use black box AI methods without explanation, if you cherry-pick AI suggestions that give desired results, or if you don't document which AI tools you used. Good practice means saving all your code, documenting AI usage, sharing computational notebooks, and using version control. Bad practice means deleting your prompts, hiding AI usage, providing no documentation, and making manual changes without recording them. Let's talk about AI-powered reference managers like Zotero with plugins, or specialized tools that can automatically extract citations from PDFs, organize your library, and even suggest relevant papers based on what you're writing. You dump a folder of messy PDFs into an AI-powered reference manager, and it automatically extracts metadata, organizes them by topic, identifies duplicates, and creates a searchable library. When you're writing, it suggests relevant citations and formats them automatically. Now let's discuss something controversial: using AI during peer review. Some journals explicitly forbid this, others allow it with disclosure. What's the ethical approach? As a reviewer, you can use AI to check for plagiarism, to help understand complex statistical methods, or to verify calculations. But you cannot use AI to write your review without reading the paper yours. That would be abdicating your responsibility as a peer reviewer. As an author responding to reviews, you can use AI to help improve clarity of your responses, to suggest additional analyses that address reviewer concerns, or to help rewrite sections based on feedback. But the scientific reasoning must be yours. Never feed a paper to AI and use its output as your review. That's scientific malpractice. It's acceptable to read the paper carefully yourself and use AI to verify specific technical claims or calculations. Here's an important practical question. Can we detect if someone else used AI to write their paper? The answer is complicated. Detection tools exist, but they're not perfect. Human writing tends to have varied style, personal voice, and occasional errors. Pure AI writing tends to be uniformly polished, use generic academic phrases, and have suspiciously perfect grammar. But the line is blurring as AI improves and humans learn to use it effectively. Let's talk about the future. AI is evolving from a tool into something more like a research collaborator. But this raises profound questions about authorship, credit, and the nature of scientific discovery. Here's a provocative question. If AI suggests the key experimental insight that leads to a breakthrough discovery, who gets credit? The human who asked the right question? The AI that provided the answer? The developers who created the AI? This is not a hypothetical question anymore. In the future, we might have research teams where AI is a central collaborator connected to multiple human researchers, each contributing their expertise. This could accelerate discovery, but it also challenges our traditional notions of authorship and intellectual contribution. Let me give you a comprehensive set of practical guidelines for using AI ethically in your research. These are not just theoretical principles, but actionable rules you can follow. Guideline 1. Always verify AI outputs. Never trust AI blindly. Check calculations, verify citations exist, and say what AI claims they say, and validate code before using it in production. Guideline 2. Keep detailed records of AI usage. Document which tools you used, what prompts you gave, which suggestions you accepted or rejected, and why you made those decisions. Guideline 3. Understand the methods AI uses. If AI suggests a statistical test, make sure you know what that test does, its assumptions, and its limitations. Never use methods you don't understand. Guideline 4. Disclose AI usage appropriately. Follow journal guidelines. Be transparent with collaborators and err on the side of over-disclosure rather than under-disclosure. Guideline 5. Preserve human judgment for critical decisions. AI can inform your choices, but you must make the final decisions about experimental design, data interpretation, and scientific conclusions. On the left, we have ethical AI use. Verify outputs, keep records, understand methods, disclose usage, and maintain human judgment. On the right, unethical use. Blind trust, no documentation, black box methods, hidden usage, and letting AI make critical decisions. Let me leave you with one final calculation that shows the compound effect of using AI ethically throughout your career. Imagine you publish one paper per year without AI assistance. Without AI, over a 30-year career, you might publish 30 papers. Not bad. With ethical AI use, you could potentially double your productivity to 2 papers per year. Over 30 years, that's 60 papers. Alternatively, you could maintain 30 papers but spend twice as long on each, making them higher impact. You could aim for Nature and Science instead of mid-tier journals. The choice is yours. Do you want more papers or more impactful papers? AI enables either strategy, but the scientific community generally rewards the latter. Let's summarize the entire AI-enhanced research pipeline we've discussed today. Literature review with Semantic Scholar and connected papers. Experimental design with power calculators and simulation tools. Data analysis with GitHub Copilot and automated cleaning. Writing with language models and reference managers. And at all stages, verify, document, understand, and disclose. Total time saved, 78 hours per paper. Here are my final thoughts. AI is an amplifier of human capability. If you're a careful, ethical researcher, AI will make you more careful and more productive. If you're sloppy and cut corners, AI will amplify those bad habits and get you into trouble faster. AI is neutral. It amplifies whatever you bring to it. Bring rigor, and it amplifies rigor. Bring shortcuts, and it amplifies problems. The choice is always yours. The real question is not whether to use AI in research. That ship has sailed. AI is here, it's powerful, and your competitors are using it. The question is how to use AI ethically and effectively to advance science, while maintaining the integrity and rigor that makes scientific research trustworthy. Remember, AI is a tool that enhances human intelligence, not a replacement for human thinking. The creativity, intuition, and critical judgment must always come from you. Use AI to handle routine tasks and free up your time for the deeper questions, the creative insights, and the breakthrough ideas that only humans can generate. Thank you for your attention. I hope this lecture has given you both practical tools and ethical frameworks for using AI in your research. The future of science is human-AI collaboration, and I'm excited to see what discoveries you'll make with these tools. Now go forth and do great science, ethically and effectively.